So where does this go next, this idea of rate of change of functions that aren't necessarily linear? Well, we figured out that as we made delta x smaller and smaller and smaller, that we were getting better approximations. So a question that maybe naturally we would ask ourselves is, can delta x ever equal 0? Well, in the sense of trying to find the rate of change, the answer is really no, because we can't divide by 0. We can't divide by 0 when using that formula delta y over delta x. But one of the things that calculus is going to let us do, calculus is going to let us calculate delta y over delta x as delta x approaches. And that's a really important word as we get ready to really start this first unit of calculus. As delta x approaches 0, and if you recall our video where we actually calculated the instantaneous rate of change, that was the language that we used. We says as delta x got close or approaches the value 0. And the reason why we're going to be able to actually evaluate or calculate this is going to be using a tool or an idea called limits, which are going to allow us to really describe the behavior of certain things, even though the function may not be defined there. So delta y over delta x is undefined as delta x equals 0 because we can't divide by 0. But we were able to make an important statement as delta x got really close to 0. And so the other thing that we really want to take away here in terms of setting the table for what's going to come next is that in calculus, we're going to replace your idea of delta y over delta x with this notation, and we'll talk more about it when we get to unit 2. But this delta y over delta x is going to kind of be replaced in your calculus brain with this idea dy over dx. And what it represents is exactly what we were finding kind of the long way by hand in that earlier video. It represents an infinitely small change in y divided by an infinitely small change in x. And so we won't get to this notation right here until unit 2, but I want you to go ahead and make that connection that whenever we do introduce it, we're really just talking about this idea of rate of change being change in y over change in x. We just want to look at it as that change in y is getting really small and as that change in x is getting really small. And if you understand that this is going to become this, it's going to serve you very well, not just here in the immediate future, but through a lot of what we do throughout this course.